Hey, how's it going? So today I'll go over the LeetCode 797 question, all paths from source to target. So given a cyclic graph of n nodes labeled from 0 to n minus 1, find all possible paths from node 0 to node m minus 1 and return them in any order. The graph is given as follows. Graph I is a list of all the nodes you can visit from node I. So basically your input is a adjacency list. So at index 0, we have 1, 2. It means node 0 can go to 1 and 2. At index 1, it has 3, so it means that node 1 can go to 3. At index 2, it has 3, so it means node 2 can go to 3. At index 3, it has 0, it means 3 cannot go anywhere, and so on and so forth. So basically your output should be, so because the graph is, the length is 4, so basically you have to find all the paths from 0 to 3. And if the graph's length is 1, 2, 3, 4, 5, you have to find all the paths from node 0 to node 4. So, and also it says it's acyclic. It means that it will not contain a cycle. So it's like one direction. It will never trapped in a cycle. So, that's very helpful, because if we use like a DFS or BFS using a queue or using a stack, it means that I will never get into a cycle. So it means that the while loop will end sometime. It will not be an infinite while loop. Okay, so you can actually use, I think the solution says something like backtracking or something, but I think you can just simply use a queue or a stack using the basic BFS or DFS traversal. So I chose to use a BFS, but it's up to you. DFS can do the same. So it's really up to you. It's really no big difference. So if you choose to use BFS, so you initialize a queue, double-ended queue, and you append, because our starting point is 0, right? Our ending point is what? Is length of graph minus 1. So for 4, length of 4, we have to go to node 3. So that's our end node, and our result is all the paths, right? So this is more like just like a basic BFS template, and you should go back to the BFS template if you're not familiar with that. Google more tutorials on BFS using a queue. Okay, so you pop your current node and the current list from your queue, and if the current node is equal to the end node, we have to end. So we append the list we have so far into our result. Otherwise, for neighbors in graph for current nodes, adjacent nodes, we append it to the queue. So we append the neighbors and also the list we have, and we have so far, and we also have to append the neighbor to the list. And at the end, we return the results. So let me go through an example. For the example 1's graph. So initially our queue is what is 0, 0. So it means that we visited 0 node, and our path is 0 so far. So we pop that from the queue. So our current is gonna be 0, and our list is gonna be 0 so far. We pop it out, right? and we say if it's equal to the end node and it's not equal, so we jump to the else loop. So for zeros neighbors, so we find this 1 and 2, right? We append something to the queue. We append what? We append the neighbors 1 and our current list 0 plus the neighbor. So we append this into our queue, and also we append, because 0 also has a neighbor 2, so we append 2 and 0 to the queue. Okay, and then we pop this. We're still in the while loop. We pop this, so our current is 1, our list is 0, 1. So we pop this from the queue. And for one's neighbor, right? For one's neighbor, so one's neighbor is 3. So we append that to the queue. So we append what? We append 3 and the list we have so far 0, 1, and 3 to the queue. And yeah. Okay, so we are done with this iteration, and then we have to pop this out. So our current is 2. Our list so far is 0, 2, and we pop this out already, right? So our current is not equal to the end node 3, so we jump into this loop. We have to find 2's adjacent list. So we find this 3. So we go into this loop, we append something to the queue. So that's gonna be the neighbor nodes and the list we have so far, which is 0, 2, and the neighbor node, right? So we are done with this iteration. We pop something from the queue. So our current node is 3, and our list is is 0, 1, 3. Okay. Oops. So we pop this out already, right? So at this point, our current is 3 is equal to the end node 3, because the current node is 3 is equal to the end node. So we jump into this if loop. So we basically append the list into our result. So we append it to the result, right? And